NASA's discovery around Mercury so far. Mercury is the smallest planet in our solar system and the closest to the Sun. Mercury is elliptical and egg-shaped. It has both orbital and sluggish rotation. The amazing fact about Mercury is that it has no moon or ring system. To find out more about this information, watch the video to the end. Hello guys, welcome back to the channel All Things Space. We are back with another blockbuster video, and in today's video you can find out interesting things about Mercury and what NASA has discovered about Mercury. And why does Mercury have no moons or ring system? What kind of surface is on Mercury? So without further ado, let's begin the video. A planet closest to the Sun. From the surface of Mercury, the Sun could appear more than 3 times as massive as when viewed from Earth, and the daylight would be as much as 7 times brighter. Mercury's surface temperatures are both extraordinarily warm and cold because the planet is so near to the Sun, daytime temperatures can attain peaks of 430 degrees Celsius. Without an atmosphere to trap that warmth at night, temperatures can drop to minus 290 degrees Fahrenheit or minus 180 degrees Celsius. Despite its proximity to the Sun, Mercury isn't always the hottest planet in our solar system. That title belongs to nearby Venus, thanks to its dense atmosphere. But Mercury is the quickest planet, orbiting the Sun every 88 Earth days. Let's take a look at the Mercury atmosphere. The atmosphere and weather of Mercury. Mercury has an extremely thin and unprotected atmosphere. For all practical purposes, the atmosphere is almost a vacuum. The scarce atmosphere consists mainly of oxygen, sodium, and hydrogen. Mercury's atmospheric atoms are constantly lost in space. These atoms are then believed to be replenished by the solar winds, and possibly by outgassing, which is the release of gas from a solid and increases as temperature increases. Mercury's tenuous atmosphere means that Mercury has no other weather than wild temperature fluctuations. Mercury even has the largest diurnal temperature spread of any other planet in our solar system. Why does Mercury have the largest diurnal temperature? This is explained by some factors. Mercury rotates on its axis every 59 days relative to fixed stars like our Sun. However, a fictional observer on Mercury would see that the actual length of the day from sunrise to sunset would be about 176 Earth days due to perspective. Mercury's orbital rotational resonance ratio is 3 to 1. All other planets in our solar system have a ratio of 1 to 1. Therefore, Mercury's very long solar day, proximity to the Sun, and very thin atmosphere combine to produce the largest diurnal temperature spread in our solar system. The sunny side can reach temperatures of near 750 to 800 degrees Fahrenheit, while the nighttime temperatures plummet to nearly minus 330 degrees Fahrenheit. The average temperature on Mercury is a balmy 354 degrees Fahrenheit. In addition, since Mercury has virtually no atmosphere to scatter, the sky would be black, even if the Sun's disk itself were more than twice the size of what we observe from Earth. Mercury has no moons. Why does Mercury have no moons like Venus? The answer may be possible because it's too close to the Sun. Any moon too far away from Venus and Mercury would be in an unstable orbit and captured by the Sun. And if they were too close to these planets, the tidal gravitational forces would destroy them. So, it all comes down to the orbital dynamics and lots of gravitational interactions. Both objects have much less gravity, which is why they aren't very good at holding other objects, such as moons, in their orbit. Both Venus and Mercury probably had moons, but they just disappeared for 2 simple reasons. One is the proximity to the Sun, and 2 is the rotation to the 2 planets. And this is important when it comes to having moons orbiting planets. The mysterious surface of Mercury. Mercury's surface resembles that of Earth's moon, scarred by many impact craters from collisions from meteoroids and comets. Very large impact basins, including Caloris, 960 miles or 1,550 kilometers in diameter, and Rachmaninoff, 190 miles or 306 kilometers in diameter, were created by asteroid impacts on the planet's surface early in the solar system's history. While there are large areas of smooth terrain, there are also cliffs several hundred kilometers long and up to a mile high. They rose as the planet's interior cooled and contracted over billions of years since Mercury formed. Most of Mercury's surface would appear grey-brown to the human eye. The bright streaks are called crater rays. They are formed when an asteroid or comet hits the surface. The enormous amount of energy released in such an impact digs a large hole in the ground and also crushes a huge amount of rock below the point of impact. Some of this crushed material is thrown far from the crater and then falls to the surface where the rays are formed. Fine particles of crushed stone are more reflective than other large pieces, so the rays look brighter. The space environment, dust impacts and solar wind particles causes the rays to darken over time. Mercury may have water ice at the north and south poles deep in craters, but only in areas of permanent shadow. In those shadows, it can be cold enough to retain ice, despite the high temperatures in sun-drenched parts of the planet. Mercury has no ring system. Mercury currently has no rings. Mercury, however, would never be able to obtain such rings. That's because it's too close to the Sun. The powerful solar winds that blow out of the Sun would melt and destroy all of the icy rings around Mercury. Ice cannot exist closer to the Sun than the asteroid belt unless it is hidden in shadows or protected by an atmosphere as we have on Earth. A planet can have rings in two ways, according to scientists. The first is the icy rings around Saturn, Jupiter, Uranus and Neptune. Scientists think that Saturn's rings came from an icy object or moon that was crushed under Saturn's gravity to become the rings. It's also possible that the ring material just formed in place when the solar system was forming. We also know that some of Saturn's moons, such as Enceladus, continue to spew fresh material into the rings. Mercury's magnetosphere. Mercury's magnetosphere is unique in many ways. Mercury's magnetosphere is one of the smallest in the solar system. Its magnetic field is typically far from the solar winds, only 1,000 to 2,000 kilometers above the surface, and for this reason, there are no closed drift paths for energetic particles and therefore no radiation belts. Magnetic reconnection on the day side of the magnetopores can affect the subsolar magnetosphere, allowing solar wind ions to impact directly on the regolith. Inductive currents in Mercury's interior can alter the interaction with the solar wind by resisting changes due to the pressure variations of the solar wind. Observations of these induction effects could indeed be an important source of information about the state of Mercury's interior. In addition, Mercury's magnetosphere is the only one with its defining magnetic flux tubes rooted below the solid surface, as opposed to an atmosphere with a conductive ionospheric layer. This lack of an ionosphere is likely the underlying reason for the brevity of the very intense but transient substorm-like energetic particle events lasting 1 to 2 minutes observed by the Mariner 10 during its first pass of Mercury's magnetic tail. Due to Mercury's proximity to the Sun, 0.3 to 0.5 AU, this magnetosphere experiences the most extreme driving forces in the solar system. And with that, we've come to the end of the video. Share your thoughts about the video in the comments below. And don't forget to give this video a thumbs up, subscribe to our channel, and we'll see you all next time. Thanks for watching. Goodbye.